warahmatullahi wabarakatuh. So let us see the question 1 of Westmark. So they are given that can homogeneity of a physical equation be used to distinguish between vector and scalar quantities? Use examples to explain your answer. So the answer to this one is that homogeneity cannot be used to distinguish between scalars and vectors. For example, speed of 2 meters per second is different from a velocity of 2 meters per second. They have the same units, but they mean different things, right? And even for displacement, even displacement and distance, even moment and work done. So those are those things that one is a vector, one is a scalar. They have the same units, but they mean different things. Okay, now let us move to the second part. Say that the speed of light in a vacuum C is related to permittivity of free space mu naught and permeability of free space and permittivity of free space epsilon naught by the equation C squared equals 1 on mu naught epsilon. Show that the equation is dimensionally correct. Okay, now to show that the equation is always dimensionally correct, please, you just have to find the base unit of the left hand side and the base unit of each term before you come back and you combine. So when we are talking about base unit, we mean you should express everything in terms of, you have everything in terms of length, time, temperature, current, mass. For your level, I think this is what you see. If you like, you can add mole, luminous intensity. Okay, now for the left hand side, speed of light, we know that speed is simply distance on time, which is meters on second, but we are squaring it, please don't forget, meters squared on second squared. Now if you move now to find the units of any of these constants, let us start with mu naught. But we know that from Ampere's law, look for any formula that you know in your mind that has a relationship between mu naught and any other quantities. You try to simplify them. We know that from Ampere's law, BDL equals to the sum of mu naught multiplied by I enclosed. I enclosed or I. So you know that the dimensions of mu naught simply be the dimensions of BDL all on I, or BL on I, since we are interested with the unit. So that is now the dimensions of mu naught. And we know that from F equals to BQV, F on QV equals to B, right? I divided both sides by this. So the unit of B will be unit of force on Q of V, on the unit of all of this. So for force is mass times acceleration. So kilogram for mass, meters per second square for acceleration. Q is our charge, and the charge is in ampere second. Q equals to IT. Ampere second, then V speed meters per second. If you simplify this, you get kilogram per ampere per second square. Now you come now to say the unit now, in conclusion, the unit of mu naught will now be what? The unit of B, which is kilogram per ampere per second square, times the unit of length, which is meters, times the unit of quarter, which is ampere, and we get that unit as the unit of our mu naught. Then our unit of epsilon naught, we go to find it by using Coulomb's law. F equals to Q1 Q2 on 4 pi epsilon naught R squared, and epsilon naught will just be Q1 Q2 on 4 pi R squared F. And we substitute the unit ampere squared, meter squared for M. 4 pi is dimensionless, kilogram meters per second square for force as above. So now we just simplify that. You see the meters, and here we'll be having meters cube, and we'll be having per second cube as well, per second to the foot, or seconds to the foot. Now we come and we substitute everything. Epsilon naught will be ampere squared, that we get ampere squared seconds to the fourth per meters cube. Now you come, you find your unit of epsilon on mu naught. You substitute every time here, second squared per meter squared, everything cancels, and then you get 1 on that will be 1 on second squared on meter squared, which is same as multiplying both sides by meter squared, top and bottom. And this meter squared will go, I believe, in meter squared times 1, which is meter squared on second squared. That is how to prove that the equation is homogeneous. And you can say, hey, you always conclude the equation is homogeneous. And that's all. Thanks for watching.